All right, guys, going through the start of our next section here, which is 9.3, we're going to extend what we know about SOHCAHTOA, and I'm actually going to rewrite SOHCAHTOA up here because it will be useful. To now triangles that are in the coordinate plane. So previously we only had triangles where the sides were positive. And if we graph triangles like we graph points, then we could have negative sides of our triangle. So we're going to use this diagram in example 1 to evaluate the 6 trig functions for theta. And we can see here's theta over here. Got some stuff going on. So there's theta right there, our angle. And no longer do we have an acute angle like inside of our triangle anymore. Now theta is outside of our triangle, and it just tells us where the hypotenuse is. So now the angle just essentially puts our triangle in a quadrant. So we have this point up here, and we're going to use that to help us get the sides of the triangle. So we see -4 was x, so that means I went -4 in the x direction here. And that would be that base, the bottom side of the triangle. And then 3 was the y, so that means we went up 3, and that's the height of the triangle there. So for these problems, we're always going to have kind of this setup where theta is not really in our triangle anymore, but still this bottom side is the closest side to theta, so that's going to be the adjacent. The side all the way over here, 3, farthest away, that's going to be the opposite. And then our hypotenuse is always the biggest side, across from the right angle there. So first thing we need to do is find the hypotenuse. So that's going to be a squared, so 3 squared, plus b squared, -4 squared, equals our hypotenuse squared. I'm going to say h squared. So we'll get 9 plus 16 equals h squared. Maybe, and if any of you notice, this is a 3, 4, 5 triangle is our Pythagorean triple, and we can see that over here when we get 25 equals h squared. Take a square root. Our hypotenuse is the only side that's always going to be positive. So lastly, we want to find all of our different trig functions, so sine, cosine, and tangent. Sine is OA, opposite over hypotenuse, so opposite hypotenuse. Cosine, A over H, adjacent over hypotenuse. And then tangent, opposite over adjacent. And it doesn't matter where you put that negative. This would be the same as writing that, right, for tangent. So remember, you can pause me if I'm going too fast or rewind or whatever you need. The last thing we need is the reciprocal functions. So sine and cosecant are reciprocals. So I'm just flipping that fraction. Cosine and secant, I always think the letters flip to S and C, C and S. So that's -5 over 4. And then tangent's usually the easy one to remember. That's cotangent. And that would be -4 over 3. So those would be our answers for this one going through. So I'll do one more example for us. Well, maybe like 1.5. I'm going to scroll down here to this guy. And this time we're graphing the triangle. So it says let 5, -12 be a point on the terminal side of our angle. So that means first I'm going to graph that point. So I'm going to go over 5. And then -12, I'm just going to say, let's put it down there somewhere. So this would be my point. And we're going to draw our triangle. So you always go from the x-axis down to your point. We don't go from the y-axis. So from the x-axis to my point, and then from the origin is where our hypotenuse comes from. So my triangle always has a side on the x-axis. And if we wanted this, where they say terminal side of angle theta, this would be the angle. The angle always goes around to the hypotenuse. All right, so we can label the sides. We went out 5 to get to this point, and then we went down 12, so I do have to put the negative, negative 12, and now we need to find our hypotenuse. So a squared plus b squared equals hypotenuse squared. Again, this is another triple, 5, 12. It should end up being 13. So h equals 13. All right, so from there, I'm going to have you guys fill in those trig functions. And if you need a little hint, remember we said that the side closest to the origin, this guy's our adjacent, all the way across, this one's always the opposite, and our hypotenuse is always hypotenuse. So I'll give us these first three, right? Sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. So you guys can finish filling out these three. And then I'm going to just wrap up with this little note thing here. All right. So here, this is just describing exactly what we did, but kind of giving a setup for it every time. So you can see in this picture, I know it's kind of small, but this was our triangle where we had X and Y. And X, we can always remember is, whoops, X is always our adjacent side. Y is always our opposite side. And instead of using hypotenuse here, they just call it R, like a radius, because you can make a circle that your triangle fits in. So instead of now just using SOHCAHTOA and writing out opposite or hypotenuse, adjacent, all that stuff, for Y, that's always standing for opposite, and R is hypotenuse. Wherever we see X, that's adjacent. But you can always use SOHCAHTOA. I like to draw that triangle every time and use that. So you guys have these two more functions to wrap up. I'm just going to set up our triangle here, and I think I'll just quickly do the sign as a quick reminder. So I've got -3, -2. There's my point. Remember, triangle comes from the x-axis, so your adjacent side is on the x-axis. My hypotenuse comes out from the origin. And here's my sides. I went -3 in the x direction, -2 in the y direction, and we can find our hypotenuse. Now, if you're using your calculator, you need parentheses. When you square a negative number, it should work out to be positive. So we get 13 equals hypotenuse squared. When we take a square root, our hypotenuse is √13. So to finish up this problem, we got to write them into all of our trig functions. Now remember, there's one extra step when we have radicals. My sign would be the opposite side. Again, y value is always opposite. So -2 over hypotenuse, always the long side. Now we are not allowed to leave a radical in the denominator. So we're going to rationalize, multiply by √13 over √13. So that would be the sign. So you guys can finish that problem up, finding our other trig functions. And don't forget to rationalize. Then we've got one more problem, and I have a nice little link you guys can follow. Check out a cool little demo there, and we'll be all set.